Hey everyone. So last lesson we looked at a bunch of different substances that I do not have in my kitchen. Most of sodium, calcium, potassium, and we saw that different things. Well, the magnesium, just sat there for a long time. It didn't really do a whole lot. It started bubbling after many, like half an hour or whatever. Then the sodium bubbled up right away. It started lighting on fire. Some things really exploded. Some things sort of fizzled out a little bit. And so we're going to shift gears and kind of think about uh, why that might be. So there's something going on, and we're hoping that you're starting to think about, well, what's going on with what's happening with um, the elements, the atoms. Some people are talking about, well, maybe something was going on with the atoms and the particles inside there. So we're going to start looking at some interactions of what's might be happening at the atomic level. And for this experiment, we're going to kind of look at some of the things that you hopefully looked at last year regarding interactions of things. So for this, you're going to need some balloons or something like a plastic comb, or something might work, but balloons. Oh, there's like picking up stuff already. So, like a chunk of broccoli in there. But you need something that will have a static charge. So you can see like there's little chunks of things sticking on here. A balloon works great. And then you're going to need some, I think, some small things to pick up. I like confetti. And so if you have some lined paper, like cut along the lines would be great. Obviously, I'm not going to cut all this while we're sitting here. Well, maybe I will, but it's kind of boring. I worked really hard on my cutting the other day, trying to get my cutting driver's license, and so I'm still not great. I don't have a paper cutter at home, but you want to make them sort of the same size confetti. Okay, and then you have these strips here. Take little strips of paper, and we're going to cut them like this. So, and I'm putting this on a cookie tray, all right? So here's some, sadly I don't have cookies on the cookie tray. That reminds me, I probably should make some cookies sometime. Does sound tasty. Okay, so we got some confetti on here. The last one, you don't want the big pieces here. And then we need a ruler. So if you have a ruler, if you don't have a ruler, you need something that's, a standard sheet of paper is 11 inches. But if you have something that is like a tape measure or whatever, you want to try to get about 10 inches of distance, okay? And so with the ruler, hang on a second. I'm going to be right back and try to find a ruler. Okay, we got a ruler now. So this one here goes to 10 inches. And so I'm going to take the balloon. And what you're going to do is I'm going to move this screen down so you can see it. But take the balloon, get some static charge, so rub it in your hair, get some static charge. And then start at 10 inches. Whoa, I exhaled very, very hard, and now I got confetti everywhere. So start at 10 inches up here, okay? And then make a note to see what happens with the confetti at 10 inches. Does anything happen? Does it start interacting at all? Okay, and then start moving it an inch by an inch, closer and closer. So 9 inches. Anything happening? 8 inches. 7 inches. Okay, 6 inches. 5 inches. Okay, 4 inches. Did you see that? I start having some things starting to move. Okay, so make a note of how many things are moving at each inch. Okay, how many pieces of confetti do you have moving? It doesn't have to start sticking to it, just needs to start interacting. So at 4 inches for me, I start seeing some interactions. I saw 2 pieces of confetti move. Okay, at 4 inches, I see some movement. 3 inches. Whoa, alright, I got 1, 2, 3, 4, 5, 6, and so on. Okay, so I need you to do this. Try to get some pictures for me. 2 inches. What do you see happening? At 2 inches, how many pieces are moving? 1 inch. Okay? And eventually 0. So as we go closer and closer, I'm going to do this again. I'm going to try to get a different angle. Okay, so I'm going to go ahead and do this again. You're going to take, if you can't do this at home, then you got to write down the data you see here. All right? So I'm just going to call it the numbers. 10 inches. 9 inches. 8 inches. 7 inches. 6 inches. 5 inches. 4 inches. Okay. 3 inches. 2 inches. 1 inch. Alright, if you want to do that, you can do that. So, that's the first experiment. Alright? I'm going to pause it and get the second experiment set up, and then we'll be right back. Alright, so that took a little longer than I thought to get set up, but now, I think we have it all ready. So, what you need for this part of the experiment, I just dropped my balloon, pick it up again. What you need for this part of the experiment is, you need the same balloon, you need 2 balloons. And you need the ruler that you used, and you need some string. So if you look really carefully, there's some string here. There's some string that's tied or taped onto the balloon. And I put it onto the ruler at about the 10-inch line. It doesn't really matter. You just want to get an idea for what's happening as you are bringing 2 balloons together. So think about, as you're doing this, think about what's going on with the charges that's causing the interactions? What types of interactions are we seeing here? And if I get my balloon charged up, so the balloon charged here, this balloon is charged, okay? And then I'm going to take them, and now I'm going to start moving them closer and closer together. So I want you to pay attention, and I'm going to try to get this to settle out here. This is 10 inches apart right now. I go 9 inches. 8 inches. What do you see happening? 7 inches. Okay, so I'm moving the string closer together. But can you see 6 inches? What's happening to the balloons as a 5 inches? Look at where the string is. The string is here and here, okay? But look at where the balloons are. I'm moving them closer together. What's happening to the balloons? Alright, my hands are almost touching now. But what's happening to the balloons? Are they touching each other? And why is that? Look at the strings. Where my hands are, they're touching now. The strings are touching, but are the balloons touching? Okay? So the strings are touching, the balloons, what are they doing? And why is that? So if I move I move it over here, you can see it a little bit better. Yep, there you go. It's against the background. Oh, now it's getting stuck to my arm. But you can see the balloons. What are they doing to each other? Why are they acting like this? As you move them closer together, as you move them far apart, do they really interact? Oh, this is stuck to my arm now. Far apart, do they really interact? As you move them closer together, what happens in their interactions, okay? So, look at that. Look where my hands are. And we're going to move now. Write down your answers, and then we're going to start thinking about that at an atomic level, what's happening with the atom, and look at a simulation that's going to hopefully help you understand this a little bit better. So, see? Strings, touching, balloons. That's what's happening. All right. Okay, so the last thing I want to do in this lesson is to look at a simulation. This is something you should be able to do at home, but what we're going to do is, if you can't do it at home, try it. Just watch what I'm doing and make sure you take notes and make observations. But we have two particles here. Right now, they are uncharged. We're going to just move the particles away from each other. So I'm going to take this one and move it over here. And then let's go ahead and charge one of these up. So if you, excuse me, if you remember the charged balloon, when we do that, we have, we get one charge from the balloon from your hair. And so that's actually gonna be negative. So I'm gonna make this one negative. And from middle school, hopefully, or at least ninth grade, you should have learned that if I have a negative charge here, well, the only way it's going to be, let's just see what happens if I just make this one. See if I make it negative. Does anything happen if I make it negative? So nothing's happening right now. What if I make it positive? So pay attention to see how it interacts, how fast it interacts at different distances, just like with the ruler. So I'm going to make it positive. So what's happening now? Is it interacting a whole lot? Or is it interacting more? All right, so that's what I want you to see at different distances. What if I make this one negative again? So I'm going to take this, make it negative, and look at how strongly it interacts at different distances. So right now they're really close together. If I make it negative, does it interact a lot or a little? When does it interact a lot? When does it interact a little? Okay, so think about, is it pushing a lot? Is it just slowly? And then let's go ahead and make this one positive. So we made this one. Okay, so let's make it positive. See, how fast does it interact? Does it interact a lot or a little? Okay, what if I do this one here? So is that interacting a lot or a little right now? Make this one positive. Does it interact a lot or a little in the beginning? Kind of note how fast it interacts. So that's what I want you to write down in your notes and your reflections. Kind of thinking, what role does distance play in the interaction of particles? And what does this have anything to do with? Look at them. They're even doing this now. They're even going to different corners. So what does this have to do with how things react, like different elements with water or other substances?